Hello friends, so here the question is calculate activity of enzyme in international unit per liter. Okay, so the details for lactate dehydrogenase LDH are given below. We have to calculate activity in IU per liter from below parameter. So here we can see given the change in absorbance is given of LDH, 20-second absorbance, 40-second absorbance, 80-second absorbance, and the reagent volume is given, sample volume is given, wavelength is there, measured product NADH, molar absorptivity of NADH is given in absorbance per mole per liter, and length of Q or diameter of cuvette is given, okay, 1 centimeter. So we have to calculate activity of enzyme. So let's solve it. Answer. Before going for the answer, we should know about Beer's and Lambert's law for this. So Beer's and Lambert's law formula to calculate activity of enzyme. Okay, from Beer's and Lambert's law, it is clear that change in absorbance A equals to molar absorptivity multiplied by B is path of light multiplied by C is concentration of that substance in solution, or in case of enzyme it is activity. So this A is change in absorbance, or absorbance is equals to this small a is molar absorptivity, B is path of light in solution, C is concentration. Okay, this is small a is molar absorptivity, this small b is path of light, and C is concentration, or in case of enzyme it is activity. And here we have change in absorbance there in table, and molar absorptivity is there in table, B path of light is there in table, C activity we have to calculate. So activity equals to what? Okay, so let's calculate it by putting in formula that A change in absorbance per minute we require here, because we have to report in IU per liter. Okay, so change in absorbance per minute is here 20 second, 40 second, 80 second, means 80 second minus 20 second absorbance is change in absorbance per minute, that is 0.08 minus 0.02 is change in absorbance per minute. Here 0.08 and 0.02 equals to change in absorbance per minute. So this is change in absorbance per minute. Okay, so small a molar absorptivity, it is given here in table, that is 6220 absorbance per mole, 6220 absorbance per mole per minute. Okay, C, that is B, that is path of light, that is also given here 1 centimeter. Okay, cuvette diameter, so that is also given 1 centimeter. Now let's put into the formula to calculate activity, that is A equals to ABC. Let's put all value into the formula. A equals to ABC. Now that C is unknown, we have to calculate C. So C equals to this big A multiply by 1 divided by AB. By simple multiplication we get this equals to this big A is change in absorbance here 0.06, we have already calculated that, multiplied by 1 divided by this small a is this molar absorptivity 6220, and this C is path of light, that is 1 multiplied by 1. Okay, So other than that, we have to consider other thing also to calculate report in IU per liter. Okay, so here one thing is dilution factor also we have to multiply to get the final report. Here the reagent volume is 1 ml and sample volume is 10 microliter, and 1 ml equals to 1000 microliter. So total dilution factor is 101. So we have to put here dilution factor also multiplied by 101. And another thing is that here we have put the molar absorptivity 6220 from here. It is in mole per minute, but we have to report LDH in micromole per minute. So because it is IU per liter, okay, international unit means change of substrate into product, micromole of substrate into product in a minute. So mole should be converted to micromole. So we have to multiply by here 6220 again 10 to the power 6 to convert mole to the micromole. Okay, now this is the final value, that C equals to A into 1 by AV. A, this change in absorbance 0.06 per minute, this is per minute. Okay, and this 1 divided by this A is molar absorptivity, B is path of light multiplied by dilution factor, and whole multiplied by 10 to the power 6 to convert this absorbance per mole to absorbance per micromole. Okay, for reporting in IU per liter. So finally the concentration, finally when you calculate all these, the concentration we get C equals to, let's put in calculator all this value, what we get, let's see here 10 to the power 6, this is 10 to the power 6 multiplied by 101 equals to this, and multiplied by 0.06 06, finally divide by 6220 220. So 974.2. This is the activity of LDH. Okay, this is the activity of LDH 974.2 from above values from this table. We calculate change in absorbance from this, and we calculate the dilution factor from reagent volume and sample volume, and we convert molar absorptivity, absorbance per mole to micromole by multiplying by 10 to the power 6. Okay, and we put in this formula A equals to ABC.